Hey everyone, and welcome. Today we are diving deep into one of the most powerful features in all of Java, threads. Seriously, if you want to build apps that are faster, more responsive, and can juggle a bunch of things at once, then you've got to understand this stuff. So let's get right into it.
So here's our game plan. We're going to tackle this in 4 parts. First, we'll get the basics down, what threads actually are and why you should even care. Then we're going to get our hands dirty and actually start creating and managing them. After that, we'll learn how to deal with let's call them monsters of concurrency, the nasty problems you'll definitely run into. And finally, we'll wrap it all up with some pro-level tips to make your code bulletproof.
So first up, what are we even talking about here? Understanding threads is it's absolutely essential for any modern developer. It's really the key to unlocking some serious performance in your applications.
Let me just ask you this. Have you ever built an application and it just felt kind of sluggish? Where one big task just freezes the whole thing up? Well, that is the exact problem that threads were born to solve.
Okay, the easiest way to think about a thread is like a single lane of traffic for your program's instructions. Every Java app you write starts with just one single lane. We call that the main thread. But the real magic, the fun stuff, happens when you start opening up more lanes, letting different sets of instructions run at the same time. And that, my friends, is the whole idea behind concurrency.
And yeah, this really nails the difference, right? On the left, you've got the old school way, do one thing, wait for it to finish, then start the next. But on the right, that's the world of threads. We move to a concurrent model where lots of tasks can all make progress at the same time. It's just a much smarter way to use all those processor cores we have these days.
And look, this isn't just some high-level theory, right? You see this stuff every single day. When you're in your web browser and the images are loading in the background but you can still scroll and click around, yup, that's threads. Or a video editor is busy exporting your file but it still lets you work on another clip. That's threads too. It's what makes modern software feel so snappy and responsive.
All right, so we've covered the why. Now it's time for the how. Let's move on from the theory and jump into the code to see how you actually create and manage these things.
So these are really the modern ways to get threads going in Java. The classic way is implementing the runnable interface. It's super flexible. But for managing a bunch of threads, Executor Service is awesome. It creates a pool of threads and just reuses them, which is way more efficient than creating new ones all the time. And then you've got the real game changer, virtual threads from Java 21. These things are incredibly lightweight, which makes them perfect for apps that have to handle thousands of tasks that are just waiting on something like a network call or a database query.
A thread isn't just running or not running. It goes on a whole journey. It starts as new, and once you call start, it becomes runnable. From there, it could get blocked because it's waiting for a resource or go into a waiting state. And when it's all done, it becomes terminated. Honestly, understanding these states is a lifesaver for debugging. Like, if you're looking at your monitoring tools and see a ton of threads stuck and blocked, that's a massive red flag that you've got a bottleneck somewhere.
And this right here, this is a classic mistake, a real gotcha for beginners. Just because a thread's state is runnable, it doesn't mean it's actually running on the CPU at that exact moment. Nope, it just means it's ready to go. It's standing in line, waiting for the operating system to tap it on the shoulder and say, okay, it's your turn.
Okay, so threads are amazing, they're powerful, but with all that power comes, well, some really nasty problems. So in this next part, we're going to face those monsters of multi-threading, the hazards that can totally wreck your application if you're not paying attention.
And the most famous monster of them all is the deadlock. Okay, imagine 2 people trying to pass each other in a really narrow hallway. Each one is waiting for the other person to move, but neither of them will budge, so they're just stuck forever. That's a deadlock in your code. It's 2 threads, each one holding on to something the other one needs, and they're just locked in an infinite standoff. So, how do you beat this thing? Well, consistency is your absolute best weapon. If you make sure that every single one of your threads always tries to get its locks in the exact same order, a deadlock just can't happen. Another great trick is to use what's called time-bounded locking. The thread tries to get the lock, but if it has to wait too long, it just gives up and tries something else instead of waiting forever.
Now, deadlock has a couple of weird cousins, starvation and live lock. Starvation is basically an unfairness problem. You've got a low-priority thread that's ready to work, but it never gets a chance because other, more important threads keep cutting in line. Live lock is kind of the opposite. It's like being overly polite. You have 2 threads that are both trying to let the other one go first, so they're both busy stepping aside. but neither one actually makes any forward progress. And finally, we have the most common hazard of all, the race condition. This is what happens when the final result of your code depends on the totally random order that your threads happen to run in. So if two threads try to increase a counter at the exact same time, you might actually lose one of the updates, and your data gets corrupted. This is exactly why we need things like locks and synchronization.
All right, we've stared the monsters in the face. Now for our final section, let's talk about how to build a fortress so they can't get in. These are the pro-level best practices that'll help you write concurrent code that's robust and ready for anything. So at a big enterprise level, you build in safety. Think of bulkheading like the watertight compartments on a ship. You split your system up into separate thread pools, so if one part fails, it doesn't sink the whole boat. Then you've got things like circuit breakers and rate limiters. They're like your frontline defense, protecting your system from getting totally swamped by a failing service or a sudden flood of traffic.
Okay, let's boil all this down to a final checklist, your key takeaways. First, and this is a big one, if data can't be changed, it can't be corrupted. Try to use immutable objects whenever you can. Second, for the love of all that is holy, name your threads. A bug report from Thread 21 is useless, but one from Payment Processor 7 tells you exactly where the problem is. And finally, be smart about your workloads. Don't let a task that's just waiting on the network clog up the line for a task that needs to do some heavy math. Use different pools for different kinds of jobs.
And that brings us to one last really important question. With these new lightweight virtual threads in Java, handling thousands of I/O tasks is suddenly way easier. But does that mean we can just forget about all the classic problems, deadlocks, race conditions, all of that? Or does having so many more threads running at once make mastering these fundamentals even more critical than ever before? That's definitely something to think about. Thanks so much for joining me today.